So what did I say when we moved Q closer and closer to P and H approaches 0? What did I say? That H could never be 0. Now I'm going to do something that will contradict that. And you should ask, why am I doing what I'm doing? Every time I'm given a limit of a function, I will plug this in. And you just, right? You should say, wait a minute. You just told us not to. Because this literally means x approaches -3 from the left-hand side with numbers smaller than -3, but you cannot touch -3. It will not be -3 ever. However, I have to plug it in. Why do I do that? Because I need to know what this is. I will not plug it in to write the answer. I will plug it in to see what type of limit I'm facing. There are so many different types. So when I plug in -3, the top is -1, and the bottom is? Okay, this gives me a lot of information. If the top is -1 and the bottom is 0, I know for sure that this kind or this type is what type? The one with hope or the one with absolutely none? No hope. So I know exactly that the answer could be
Positive infinity, negative infinity, does not exist.
right. Awesome. Now, the second step is, and this is again for your notebook, we're going to do this over and over, -3 from the left. Can you give me a close number from -3 to from the left? Close as you can think of. From the left. -3 point. -3.1. Okay. -3.1 plus 2 is still a negative number. -3.1 plus 3, what type of number would that be? So then a negative number over a negative number will give us an answer that is positive. So then from those 3 possibilities, which one is it? Is that clear? So this is what we call an infinite limit. Since this is a rational function, and the limit from the left-hand side of -3 is infinity, what does x equal -3 represent?
The vertical asymptote.
Exactly. Because one or the other, not necessarily both, one or the other goes to, the function values go to. So x equals -3 is a vertical asymptote for this function. Any questions here? Yes, please. Correct, yes. So first of all, although I'm not allowed to do that, I have to do it. I have to plug in the number that x approaches to see what type of limit this is. Because it could be a number, right? So let's say this is not x plus 3. Let's say it's x plus 5. Okay. -3 plus 2, -3 plus 5, I have a number, and I'm done. I don't have to do anything, right? The numerator would be -1, and the denominator would be 2. So the answer is -1/2. So I have to plug it in. Now, in this case, when I plug it in, it turns out that -3 plus 2 is -1, and -3 plus 3 is 0. So right now, I established the fact that this limit cannot exist. A limit that does not exist is like a number, not 0, any number but 0 over 0. And this is what I have. I have a number divided by 0. So then there's only one correct answer. Infinity, negative infinity, or DNE. That's all I have to establish. So now, from the left-hand side, the next step will be to pick a number that is close to -3 from the left, like -3.1. Still, this is still -1. That will not change. But -3.1 plus 3 is a negative number, right? So this becomes a negative number. A negative number over another negative number, the answer is positive. Is that better? Very good. Okay, so let's look at 36. And also, I would like to look at, yeah, that's good enough. Yeah, unless you want to choose something else, please do. So 36. So this is limit. Sx approaches 2 from the left. From x squared minus 2x, everything divided by x squared minus 4x plus 4. Oops. Okay. I'm asked to find this limit. I have no idea what to do and what type of limit this is or ends up being before I plug it in. Okay, so when I plug it in 2, what do I get at the top?
0.
Excellent. When I plug in 2 in the denominator?
0.
Right, so at this stage, I will say, I think there is hope because it's 0 over 0. It's not 5 over 0. 5 over 0 will have absolutely no hope. But it's 0 over 0, so there is hope that the limit is 15 or whatever, a number, any number. Okay, I would like to review something before we continue, which is called the remainder and factor theorem. This is something from pre-calculus that you may have been taught or not. It doesn't matter. Let's talk about it. So here it is. If I divide 9 by 3, what do I get?
3.
And what is the remainder?
0.
So why is the remainder 0? There's no remainder. 9 divided by 3 is 3. There is no remainder, correct? Why is the remainder 0? Exactly, that's all I needed to say. Right, since 3 is a factor of 9. So if a division does not have a remainder, it means that this quantity is a factor of this quantity, correct? 3 is a factor of 9 because there is no remainder. Okay. So now, when in a polynomial, so let's say I have a polynomial p of x, and I divide it by x minus 2. Let's say the remainder is 0, since x minus 2, correct, is a factor of, excellent, perfect. So all this was basically the factor theorem. But now what's with this, right? They're connected. So the remainder is 0, and that it gives us the information that x minus 2 is a factor of p of x. So now about the remainder. Of such division, how do I find the remainder? Anyone remembers? So I have a polynomial divided by x minus 2. How will I find its remainder? You can say use the long division, divide, and see what the remainder is. But there is another way. Synthetic also. Perfect. So synthetic or long division. Another way. I want a third way. How will I determine for this? I don't want to find the quotient. How will I find the remainder of this division? P of x over x minus 2. The remainder will be P evaluated at? Exactly. Yes. So if I want to determine this remainder of this division, all I have to do is plug in 2. What if I have a polynomial divided by x plus 3? As another example, how will I find the remainder of this division? Indeed, p of negative 3. If it happens to be 0, what will I say? If it is 0, what will I say about x plus 3? A factor of the numerator. Okay. Now all this discussion was for this. What did we do? We plugged in 2 in the top polynomial, then we got 0. We plug in 2 in the bottom polynomial, and we got 0. What do I know for sure? And if I need to repeat this from scratch, I will. This is very important. What do I know for sure about these two polynomials? That both of them have a factor of x minus 2. X minus 2. This is crucial. Let me start from the beginning. We need to understand this one more time. 9 divided by 3 is 3 because the remainder is 0, right? Which means that 3 is a factor of 9. If I divide p of x by x minus 2, and it happens that the remainder is 0, I immediately conclude that p of x is divisible by x minus 2, or x minus 2 is a factor of p of x. And how do I determine that? It's connected to the remainder theorem. So how would I determine or find the remainder? By simply plugging in 2. That's the remainder theorem. So if I have a polynomial and I divide it by x plus 3, the remainder will be p of negative 3. If this happens to be 0, then x plus 3 is a factor of p of x, or p of x is divisible by x plus 3. So coming back to our problem, because we're going to need this for moving forward. Once we plugged in 2 in this polynomial, we got 0. And we plugged in 2 in this polynomial, and we got 0. Specifically 0. It means that the numerator has to have a factor of x minus 2. And the denominator has to have a factor of excellent. Always keep that in mind when you get 0. So I'm going to write the problem here one more time. Limit as x approaches 2 from the left. And please tell me, what do you factor at the top? So you have an x minus 2. And what do you factor at the bottom? So you have an x minus 2. I know it must be there. Indeed, at the top, just x. And what about the denominator? It's a trinomial. We reviewed it on the first day of classes. I don't want to hear that, please.
Yes.
Very good. So please, that is the first step you have to review. Those 3 special products that we reviewed on the first day of classes. I need this forever. And you need it forever, yes.
Where did we get the x minus 2 from looking at like the equation?
At the top, you factor out x. At the bottom, the special product from the first day of classes, x minus 2 squared.
Okay.
Is that clear? X minus 2 squared is a trinomial, x squared minus 4x plus 4. Are you with me? Any questions? Okay, what do you think we have to do next?
Plug in 2.
Yes, simplify. Simplify. Remember the 2 keywords? Remember? What are the 2 keywords? Factor and simplify. Never forget these 2 keywords, please. Good. So I remove a factor of x minus 2 from the top and a factor from x minus 2 from the bottom. So remember what we said. What did we say about the limit initially? It was 0 over 0. So what did we say? What was the first assessment? There was hope. Okay. So we simplify the factor of x minus 2 from the top and a factor of x minus 2 from the bottom. Now let's plug it in again. The top is,
2.
the bottom is,
0.
uh-oh. So remember what I said, 0 for 0 has hope. I did not guarantee that the limit exists. It turned out in this case that it will not. And we know there are 3 possibilities, only 3. What are those? Excellent. So now I have to identify which one it is. Since it's 2 from the left, give me a close number from the left of 2.
Negative 2.1.
1.9, right? 1.9. So this is, yes, 1.9. This is still a positive number. 1.9 minus 2. Negative. So what will be the final answer of this? What does this say to us? Or what does this say about the function? When x approaches 2 from the left, the function values approach negative infinity. What does this mean?
Does not exist.
that x equals 2, indeed, x equals 2 is a VA. Guaranteed. You understand why? As x approaches 2 from this side and the function values get to negative infinity, this must be a vertical asymptote. Is that clear? Yes.
Under what circumstances could you plug in the number and it does not exist?
So you
Because
plug in
all
on,
of them would be infinity or negative infinity.
because we're talking about infinite limit.
Okay.
Yes. So when you plug it in and the limit exists,
Okay.
and it's 0 by 0 initially, in many situations.
Okay.
We'll get to that. I promise.
Okay.
I'm not sure I answered your question, so your question?
No, I think I understand. We're just not dealing with that right now.
Okay. Good. But your question was, we plug in and the limit does not exist, and this was the situation, or we plug in and the limit exists.
It was under what circumstances could the limit be does not exist? Because it seems like if it's either positive or negative, it has to be an infinity.
If it's 0 in the denominator
Okay.
and a number other than 0 in the numerator, this will be the case.
Okay.
Yes. But if it's 0 by 0, it may turn into this, but at the same time, it may turn into a limit that exists. Is that better? Very good. Other questions for me? Any questions? Any questions? Okay, I do have 4 minutes left. I can start the next section with the limit laws. However, I would like to assign some homework here for you to turn it in. Don't forget to turn in your homework before you leave. I still have a few more minutes and I want to work on one more problem. But for now, I want to choose for Thursday. I would like you to work on problem 7. And this is on page 96. I would like you to work on problem 11 on page 97. 17 also on 97. And 31 on 98. And now I would like to choose another problem, like, for example, 37. And then after 37, we'll stop. And I would like to see as many of you today after class, if you have time to work on something or, yes, Vanessa?
So 7, 11, 17, 31, and 37?
No, I'm doing it to 37 right now.
Oh, okay.
37, limit. As x approaches 2 from the right-hand side, from x squared minus 2x minus 8 divided by x squared minus 5x plus 6. I would highly appreciate it if you would have, moving forward, just maybe a folder or a binder or something in which I see all your homeworks. And you just add on to that and I'll return the whole folder back. I would love to have that to have a record of your progress and see how you are doing better and better every day. Okay, so what do I have to do? I'm asked to find this limit. I have no idea what it is. I have to plug it in, although theoretically I'm not allowed to. Because when we say x approaches 2, we mean approaches 2, not equal to. But I don't know what this is. Okay, so when I plug in 2, 4, so this is negative 8 at the top, okay, and the bottom is, so the bottom is 0. So I know that for this limit, there will never be hope, the limit will never exist. So now, I will have to identify a number as close as possible to the left-hand side of 2, to the right-hand side of 2, 2.1. So the numerator will not change. That will still be negative 8. But with 2.1, we can plug it in and calculate. So 2.1 squared minus 5 times 2.1 and plus 6. All I care about is the sign of this expression. I don't need the exact number. I only care about the sign. So this is negative 10.5. Will this be more than negative 10.5 or less? If it's more, the answer is positive at the bottom. If it's less, then the answer is negative at the bottom. So what did we get?
Positive.
So this is positive, and then I know the answer. Negative infinity, which makes x equals to what?
A vertical
A vertical asymptote of this function.